Hello and welcome back. I am Benjamin Williams, and today we're still within the infrastructure section within Boson NetSim. Today we're going to be doing a lab on dynamic NAT. So as we know, we have PAT, we have dynamic NAT, and we also have static one-to-one NAT. So right here, the objective for this lab is to configure a simulated network to translate private IP addresses to public IP addresses that could be used on the worldwide network WAN by using network address translation NAT. Your NAT implementation will use a range of public IP addresses that will be used by hosts on the private network when accessing the public network. You will configure NAT functionality on router 4. So we're going to be doing all of our configuration right here on router 4. And as we can see, it has a public IP address, which is 180.10.1.0/24 between R4 and R3. And we can see the private IP address range of 192.168.1.0/24 within our internal LAN. Okay, so we have already read through all of the commands and also the descriptions for this lab. I've reviewed the IP address information in this table, and that's always good information to have. So let's go ahead and read our lab task starting right here. So it says lab task. Dynamic NAT is used to map a range of inside local IP addresses to a range of global addresses in a one-to-one relationship dynamically. The global IP addresses in the pool are associated with private addresses as needed. In this lab, an internet service provider, ISP, has assigned the global address range of 180.10.1.0/27. Your objective is to properly configure NAT to allow PC1 and PC3, which are hosts on the private local area network LAN, to use dynamic NAT to access the public IP addresses in the simulated network. Private IP addresses, as defined by Request for Comments RFC 1918, are IP addresses that are used by networks that are not directly connected to the public internet. Yes, that's right. This RFC designates Class A, Class B, and Class C private address blocks that are available for organizations to assign to their internal networks. Yes. The simulated network in this lab uses the private 192.168.1.0/24 Class C network. In order for hosts on the private networks to access the public internet, NAT must be used. Private IP addresses are not routable on the public internet and are usually filtered by ISPs. Yes, that is true. It is also a good practice for operators of private networks that connect to the internet to use filters at their network edge to prevent any privately addressed IP traffic from exiting their network. Great. All right. So it says the password in this lab has been configured as Cisco. Okay. So right here, we're going to be doing all of our configuration down here at the bottom as we usually do. So let me go to router R4 because this is the router that we're going to be using. Let's hit enable. Let's type in Cisco as the password. Let's go into global config mode. Perfect. All right. So we're going to keep our lab topology in the top left. We're going to be doing all of our lab readings in the top right and our configuration down here at the bottom. Let me turn my camera so you guys can get a little bit of a better view of the CLI. Perfect. So first, I should say not say first, number one. The first lab task we have is to attempt to ping from PC1 to router 3. Router 3 has an IP address of 180.10.1.1. So let's go to PC1. All right, from PC1, let's ping to 180.10.1.1. And as you can see, we cannot access the public IP address of 180.10.1.1 because we're trying to access that through the private IP address range, and that is being filtered by the ISP. So that's not going to work. So we need to configure NAT on R4 to be able to translate our private LAN IP addresses to one or multiple public IP addresses so they can reach the internet. All right, so that's what we're going to do. It says on router 4, create ACL2 and configure it to select subnets of which PC1 is a member as the range of IP addresses that will participate in NAT as inside IP addresses. So let's go to R4. All right, we're already in global config mode. So let's do access list. It wants us to do an access list number 2. And we're going to permit, let's go ahead and permit the 192.10 192.168.1.0, and we want a wildcard mask of 0.0.0.255. All right. So it says okay, let me highlight the next part. It says on router 4, curate the pool of IP addresses that will be used as inside global IP addresses named NAT pool. Use the address range of 180.10.1.5 through 180.10.1.15 from the addresses made available for use by the ISP. Okay, so the first thing we need to do IP. Oops. Let me go back up to our instructions. Okay, go that down back here. All right, so we want to do an IP NAT. Let's get some context sensitive help. We want to create a pool. And the pool name is going to be NAT-pool. And the starting address will be 180.10.1.5 through 180.10.1.15. And it says specify the subnet mask. So let's do a net mask of, and we can see that we had, let's go back up. We can see that we're doing 180.10.1.0/27. So let's pull up a calculator. And we know if we have a /27, that'd be 180 plus 64 plus 32, and that gives us 224. So we're going to have a net mask of 255.255.255.224. Oops, 255. I hate these red dots are coming up, kind of blocking the output. 255.224. 224. All right, so we hit enter on that. All right, now let's go back down. All right, so we just created our NAT pool with the address range that it wanted. Perfect. Now it says on router 4, enable dynamic NAT by combining the list of local IP addresses created by using access list 2 and the list of inside global IP addresses created by the NAT IP address pool. Explain the syntax and purpose of the command you issue. All right. So first off, let's do an IP. We'll have caps lock on. IP NAT. We're going to do inside. You want to do a source list 2. We want to do the pool of NAT pool, because that's the pool that we created. And we don't want to overload because that will be doing PAT. So we're doing IP NAT inside source list because we're doing the list that we just created. And the list that we created was to permit the 192.168.1.0 network. And we want to translate those inside IP addresses to the NAT pool that we created. And the NAT pool that we created has the addresses of 180.10.1.5 through 180.10.1.15. So that's perfect. So let's hit enter there. All right. So now on number 5, it says on router 4, configure the NAT inside and outside interfaces. So we can see here that the serial 00 is going to be an outside interface, and the serial 01 is going to be our inside address. So let's go into interface serial 00. Then we want to do IP NAT outside here. Then you want to do an exit, and let's go into interface fast Ethernet 01. Let's do an IP NAT inside here. Let's do an exit. All right, now it says verify that you can ping from PC1 and PC3 to router R3, which has an IP address of 180.10.1.1. It says the ping should be successful. So let's go back to PC1, hit the up arrow, see if we can ping. And we're getting replies now from router R3. Before, you could see that we timed out, but now that we're using a global IP address, we're able to ping the router 3, which is good. So let's go to PC3. Let's do the same command. Let's do ping 180.10.1.1. And we're getting replies from router 3 as well, from PC3. So it says, on router 4, display the NAT translation table. So let's go to R4. Let's do an exit. Let's do a show IP NAT translation. All right, so we can see our IP NAT translations right here. So it says NAT is configured on the router that has one interface which connects to the inside network, inside local, and another interface that connects to the outside network, inside global. The output of the display should show that the inside local IP address of PC1, which is 192.168.1.2, and the inside local IP address of PC3, 192.168.1.3, have both been translated to the inside global IP address of 180.10.1.5. Why is the same inside global address used for both PC1 and PC3? So let's just confirm that. So we can see that our inside global IP address that were used for both of these were 180.10.1.5. And we can see that their inside local IP addresses is the 192.168.1.2 for PC1 and 1.3 for PC3. Okay, and we can see that they're using two different port numbers as well. So that can be one reason why we can just use the same inside global IP address and use different port numbers. So when the traffic comes back in, it can identify which PC the traffic belongs to based off of the port number. Also, they communicated at two different times. So we did a ping on PC1, and then after that, we did a ping on PC3. So they weren't transmitting at the same time. So that can be another reason why they use the same inside global IP address. So let's hit grade now, and hopefully we did everything correct on this lab. And we did. So thank you guys for watching this one, and I'll see you in the next one.